So I'll be just discussing the Kelly Criterion. So firstly, what is the Kelly Criterion? So it's a formula that gives the optimal fraction of your bankroll that you should be wagering each time in order to maximise the growth rate of capital whilst also avoiding the risk of ruin. So it's a fixed fraction. So this means you constantly bet the same fraction of your current wealth. So because you're only betting a fixed fraction, you're avoiding the risk of ruin. And this means that the amount you'll be betting each time will be dependent on your current bankroll. So the Kelly criterion can only be used when the gambler has an edge. So this is when the person knows that the odds are slightly better than the odds that are being offered. So for example, someone would have an edge if they knew that a coin was biased, for example. So in 1956, John Kelly came up with a formula which he called the Kelly gambling system, and that could be used to maximise a player's wealth. And Edward Thorpe then came across this formula in 1960, and he extended it to the field of finance and then renamed it the Kelly Criterion, which it's known as today. So the formula is F star equals BP minus Q over B. So F star is the optimal fraction that you should wager. B is the decimal odds minus 1. P is the probability of success, and Q is the probability of failure. So this can be reduced to 2p minus 1 for an even money coin toss. So that's because the decimal odds for that is 2. So 2 minus 1 gives b just equal to 1. So Kelly's formula is typically used in blackjack or sports betting, but it can also be used in the stock markets, where the main objective would be to invest so that you maximize the expected growth rate of your capital or your wealth. So optimal Kelly, which is the F star just from the previous formula, avoids the risk of ruin. So this is because you're always only betting a fraction of your current wealth each time, so you can never actually lose all of your money. You can also use a fractional Kelly. So this is where you can either use a smaller fraction than what Kelly suggests, and typically this is half Kelly, or you can use more than what Kelly suggests, and typically that is double Kelly. So this usually would depend on the edge and the individual's risk aversion. So if a person would rather win less, if it also meant that they would reduce potential losses, then they could use a smaller fraction. Whereas on the other hand, if the individual is willing to take a risk and decides that the possibility of increasing their winnings is worth potentially going broke, which is possible if you use a larger multiple of F star, then they could use a bigger fraction. And this can be seen in the plot here for the expected bankroll. So when a coin is tossed 10 times, by the 10th toss, you can see that double Kelly has, which is the green line, has a significantly larger increase in bankroll than both full Kelly and half Kelly. But looking at the standard deviation, which is one standard deviation, which is represented by the dotted lines, there is much more variability in double Kelly than there is for full Kelly or half Kelly. So the optimal Kelly is the blue line in the middle. And depending then whether or not you're willing to accept the variability that double Kelly gives, you can choose either a smaller or larger fraction of F star. So although there is more variability in double Kelly, it's still a much safer option than other strategies, for example, double or nothing. So this is where you bet your entire bankroll on the favourable outcome each time. And then each time that outcome appears, you double your current bankroll. And as soon as the unfavourable outcome appears, you lose everything and you go to ruin. So while this does significantly increase your wealth when the favourable outcome appears, as soon as that doesn't happen, you lose everything. That's corroborated in these plots here. So this is the 4 possible outcomes when a bias coin is tossed twice. So when the players bet €20 on heads, when the probability of heads appearing is 60%, we can see that when heads appears twice, the double or nothing strategy gives a much larger increase in the player's bankroll. But as you can see that in the other 3 plots, that as soon as tails appears, the double or nothing strategy causes the player to go broke. Whereas Kelly's 3 fractions, which are, I use the double Kelly, full Kelly and half Kelly, they ensure that even when tails appears twice, that the player's bankroll still doesn't go to zero. So here we'll compare the probability of making a profit when half Kelly, full Kelly, and double Kelly is used in the long run. So starting with an initial bankroll of €10, when 1,000 coins are tossed, the probability of making a profit that's greater than or equal to €10 is almost 1 for full Kelly and half Kelly, so it's 0.999. This means that if you use either of these two strategies, you can almost guarantee that you'll make some sort of a profit. Whereas for double Kelly, the probability is much less, so it's only around 44%. So this shows that in the long run, if you overbet and use a fraction of Kelly that is too high, you have a higher probability of losing money. So this is my future plans for next semester. So I hope to extend the use of the Kelly Criterion to the stock market, which is where an investor would use F* to decide how much they should invest on each trade. And I'm happy now to answer any questions that you might have.